Today I want to hit the main ideas and some of the details behind the L'Hopital's rule, which is how to handle limits that you can't get right away. For example, if I took the limit as x approaches 0 of sine x over x, what did we say that was? We said it was 1. But here is something kind of interesting. If you took the derivative of sine, what's the derivative of sine? Cosine. We did that yesterday. So what if you took the derivative of sine, which is cosine, and then you took the derivative of x, which is 1, and evaluated this at 0, what is this going to be? This is the cosine of 0 is 1 over 1. So this actually works in some cases. And for indeterminate forms, we'll find out what that means. All you need to do is say that the limit as, we'll call it x equals 0 here, of f prime of x over g prime of x will be equal to the limit of f of x over g of x. So a couple of things that you need to be aware of. Number one is that you have an indeterminate form. And you have to actually list that for IB. You have to actually say this is an indeterminate form. And I'll show you which ones they are. 0 over 0 is the most popular one. Infinity over infinity is the second. The second thing is you have to have a format of laying out the functions f of x over g of x. If you have these two things, you're going to be able to use this method for finding limits. All right, so now, what is the deal with these indeterminate forms? Well, for IB, what we'll do is we'll plug the value in first. And if you get 0 over 0, that is not undefined. It could be, but it doesn't have to be. It could be undefined, like let's say I took the limit as x approaches 0, and you had x squared minus 1 over x cubed. And I put in a 0. I guess this would have to be an x, wouldn't it? So this is 0 over 0, but is this going to give me a number like 4 or 3 or even 0? No, it'll be undefined. So they could be undefined, but the first step that you do is you want to plug the values in and get one of these. And of course, these are the two that you're going to see the most often. The weirdos are infinity minus infinity, 0 times infinity, 0 to 0, and 1 to the infinity. This 1 to the infinity you're very familiar with, which we'll look at a little bit later today. Let me prove just one of these where the 0 over 0 one works. So let's say that we have a y value equals 0 of one function and a y value 0 of another. 0 over 0. So we take the limit as x approaches c of f of x over g of x, and you plug that c in and you get 0 over 0. Okay? Well, this can be, if you extend this out, is this a legal algebra move? That's still equivalent, isn't it? So then this is equal to the limit as x approaches c of f of x, and we already said 0 was equal to f of c, right? And 0 is also equal to g of c. See how I did that? Pretty clever. And now I'm going to take this, actually it's already there, and I'm going to clone it, and then I'm going to divide the top by x minus c, and the bottom by x minus c. It's like dividing top and bottom by x. Legal? Mm-hmm. So then we'll have the limit as x approaches c, f of x minus f of c over x minus c over g of x minus g of c over x minus c. Whew. What is this? Well, I don't like the crayons. What is this equal to, and what's the yellow equal to as x approaches c? What is that? Anybody know what f of x minus f of c over x minus c is? It is the derivative at c, or in this case, x. And what's g of x minus g of c over x minus c? The derivative of x. C is a value. We could use 0. We could use anything. And now, oh, actually, yeah, C is the value that makes y equal 0. There's your L'Hopital's rule. So we could do that, and we just did. What's the derivative of sine of x again? Oh, wait. First thing we got to do, plug in a 0. So sine of 0 is 0. 0 in for x is 0. Would you get in the habit right now on a test for me and IB of plugging the value in first and then writing IF? Because you have to do that for a point in IB to get that indeterminate form point. Then this allows us to write limit as x approaches 0 of the derivative of sine, which is what? Cosine. And derivative of x is 1. So here's where we get cosine of 0 over 1, which is 1 over 1. You try these three. So for number 2 here, limit as x approaches 0. When I put a 0 in, I get 1 minus the cosine of 0, which is 1 over 0. What's 1 minus 1? 0. So it's 0 over 0, which is an indeterminate form. And I write the letters IF, because you have to. Then I write the limit as x approaches 0 of 1 minus the derivative of, or actually that, what happens to the 1? Yeah, so that's 0. Derivative of cosine is negative sine of 0.
Yes.
It won't matter, but in this case, the derivative of cosine is negative sine, so that negative cancels out. And what's the sine of 0, though? 0 over 1 is 0. So this thing is equal to 1, as we proved yesterday, and this is equal to 0, as we proved yesterday. What's the derivative of the natural log of x? 1 over x. And we'll review that one too. But so if the derivative of natural log is 1 over x, put a 0 in. What is the natural log of 0 from the plus side? Negative infinity. The opposite of that is infinity. And cosecant at 0, that's kind of a dirty trick too. Cosecant. Here's sine. Cosecant is 1 over 0, which is undefined. So what's going to happen is as you approach this from the plus side, this is going to be positive infinity, right? Don't worry about that, but this will just be infinity over infinity. Is that an indeterminate form? It is. It is an indeterminate form. So we can rewrite this as the limit. X approaches 0 from the plus side. Derivative of natural log is 1 over x. Derivative of cosecant? Negative Cosecant x, cotangent x. Good. Good. Huh? This one?
Yeah.
It's the graph of cosecant x.
So it's 1 over sine.
It's 1 over the sine. So here's the sine of x. Here's the cosecant. And it's going to be this part here, going up to infinity. All right, now, we're going to put a 0 in here, but we've got a little bit of rearranging to do. I have 1 over x. Cosecant is 1 over the sine of x. And the cotangent is 1 over the tangent of x. So the tangent of x is sine x over cosine x. So when you put a 0 in for this rascal, what's the sign of 0? 0. So all of these zeros, and what's cosine of 0? 1. So we don't have anything or an x is in the denominator. We have 0 times 0 times 0 over 1, which is what? 0. So that limit is 0. And then we get to the last one here, and this is my favorite. The limit as x approaches 0 from the plus side of x times the natural log of x. Now plug values in here. You're going to get 0 times infinity, actually negative infinity. Now, is that an indeterminate form? Let's check. 0 times infinity. It's a weird one, but it actually works. So what you're going to do here is, I told you there was 2 requirements. One is 0 times infinity is an indeterminate form. You have to write that. The second thing you have to do is to write this as a ratio of 2 functions, or this won't work. I'm going to keep natural log of x on the top. What could be a function down below here? Turn to your neighbor, see if you can. Yep, 1 over x. This is the equivalent of this, right? So if we wanted to, we could write this, the limit x approaches 0 from the plus side of the natural log of x over x to the negative 1. Now we're going to take the derivative of it. Limit as x approaches 0. What's the derivative of 1 over x? Or natural log of x? 1 over x, yes. What's the derivative of this one? Negative x to the negative what? 2. Let's do that again. Derivative of 5x to the negative third. That's going to be 5 times negative 3, negative 15, x to the negative. What are you going to do with this power? Drop it 1, yep, negative 4. So we're going to do the same thing with x to the negative 1. Okay, it's going to be negative 1 times 1 is negative 1. X to the drop it, negative 2. So rewriting this, you get the limit as x approaches 0 of 1 over, fractions, negative 1 over x squared. Where does this x squared go? On the top, yep. So you get the limit as x approaches 0 of negative x squared over x. Because this is the numerator, this is the denominator. What's below the big line? Denominator, and then this will be the numerator. Hang in there. So then this is going to cancel out one of the x's, and so you're going to get the limit as x approaches 0 of negative x. And what will that be? 0, yeah. There you go. So a little tough. Let's go over it just kind of real quick. I plug the values in. 0 times natural log of 0 is negative infinity. 0 times infinity is an indeterminate form. So we had to label that. Then I rewrote these so that this was in the numerator and this snuck down to the denominator. The way I do that is I just call it 1 over x, or x to the negative 1. I rewrite these because I can take the derivative of x to the negative 1 easier than I can visualize this derivative. So the derivative of natural log is 1 over x. Derivative of x to the negative 1 is negative x to the negative 2. Rewrite those, and you're going to pull this up in the top, and that's where the negative x squared over x comes from. I think that's enough. I think that's enough to do. So we're going to sneak on down to the homework and just start plowing through these. Plug in first and see that you get an indeterminate form. I listed them at the top here. I think on each page, because I'm nice. Okay, and then label it. So this first one, limit x approaches 0, 1 minus the cosine of 0 over 0 squared. This is 1 minus 1 over 0. Is that an indeterminate form? Yep, and then you go from there. So all of these, I want to see this first, and then take the derivative of the top function over derivative of the bottom one. One quick little hint that I want to share those to the video audience, I'll share it with you too, is that what was the derivative of high over ho? Ho d high minus high d ho over the square of ho we go. All right? So that's what derivative of high over ho is. I want you to recognize when things are different, and L'Hopital's is different. We are not doing high over ho for these. We're doing just the formula said, just take the derivative of the top and the derivative of the bottom. All you have to do is take the derivative of the top and the derivative of the bottom. That's different than high over ho. It only works for limits, and it only works for indeterminate forms for those limits. So just a quick reminder, you don't do high over ho for these. You're not going to do this for L'Hopital's. It's different.